This is Jacob Gillespie and Wyatt King, and this is our SolidWorks modeling of a skateboard. This is in the class Drafting 170 Engineering Graphics in the fall of 2022, and our instructor is Dr. Hans Chapman.
This is our reference model that we referenced our skateboard off of. This is Jacob's skateboard that he brought in, and it allowed us to get accurate measurements so that we could more accurately create a model of the skateboard.
This is the rough sketches that we drew from the beginning to help brainstorm our ideas and find the exact dimensions of the board. The board was roughly 53 centimeters long and 20 centimeters wide, and we drew the front and top views of the board and the front and top views of the wheel and the bearings, and then the front and top views of the trucks and the truck plates. We started modeling in SolidWorks with the board, and we modeled using some extrude and fillets and extruded cuts to model the board. The board was made out of maple wood to represent accurate representation of what an actual skateboard would be in real life.
To model the wheels, we used extrude boss base feature on SolidWorks, and then we used the extrude cut feature to get the inner ring, and finally we used the fillet feature to give it more of a round shape to make it a more accurate wheel. For the material, it would be made out of rubber, as it would provide the most friction and therefore the most stability and grip when riding an actual skateboard, so that's why we went with rubber. So on the very left side, figure 7 is the SolidWorks bearing assembly. We did this in 2 steps, where the first step we used the revolve feature to make the actual rails and the rings that the bearing balls would go into. And then we also used the revolve feature to make the actual spheres inside of the ball bearing, and went into assembly mode and created the ball bearings themselves using the 2 pieces.
Then on the right side of the screen you see figure 8 and figure 9 were the parts made up for the truck. The trucks were made in one main shaft with a cylinder model that was made from just creating a few circles and extruding the boss and base, and then figure 8 was done through several parts to create an assembly. There was the cylinders, and there was a few extruded boss faces of rectangles to create the actual plate itself, and extruded cuts to create the angles, and then we created the whole placement for the truck shaft to fit into on the assembly.
From left to right, figure 10 is the screws that actually hold the board part of the assembly to the plates under it, and also hold those 2 pieces to the trucks. We modeled these screws using the extrude boss base feature, and figure 11 shows the SolidWorks hex nut model. This is what screws onto these screws and also helps keep the board connected to the trucks and the plates underneath the board. We use the extrude boss base feature as well as the sketch feature, sketching the hexagon shape and then extrude cutting it to give it the hexagon shape as a whole. We also use the chamfer feature just to give it more of a sleek design. And figure 12 are the truck hex nut models, which connects the screws onto the end of the truck cylinder and keeps the ball bearing and the wheel on the actual truck itself. This is just the skateboard assembly. This is what all the parts look like once we assemble them. You'll get a better image and better picture of how they all fit together in the next few slides as we go over the exploding and collapsing view. This is the drawing document. We have the front view, the top view, the right side view, and isometric view.
The materials of this were made out of maple, aluminum alloy, and stainless steel. The aluminum alloy was made from the trucks and the plates and the bearings, and the stainless steel was used for all the screws and nuts. The rubber was for the wheels, and the maple wood was for the board. and this is our drawing document. We also did a load simulation to give a representation of the load and weight and force and how it would bear that load. These aren't the actual materials of the board that we did in SolidWorks, but we used ABS plastic and pure gold as two comparing load simulations. The one on the left in figure 15 is the load simulation with ABS plastic, and the one on the right is 775 newtons. Is the pure gold. Both of them were 775 newtons, which is roughly 175 pounds, which is an average human being's weight. And as you can see, the most stress on both of these models was right at the curve point of the angled side of the board. This is our first animation, and it's Explode, and it shows all the parts of the whole assembly coming apart, from the board to the truck plate assembly to the bearings and the nuts and the screws, showing how they all work together. And this is the collapse animation, and it is showing just the reverse system of everything coming back together, how they all fit into place.
Some skills that we learned were time management, especially near the end. We were crunched for time, but we learned not only how to time manage and delegate specific processes to each other, but the importance of time management. We also learned teamwork, as there was a lot of teamwork and collaboration on this project. It wasn't just one effort, but the both of ours combined. We learned how to be adaptable, as there were some hiccups along the way with things like the animation and some of the simulation, and we learned how to just move along, kind of roll with the punches. We learned problem solving, especially through the brainstorming step of this assembly and just figuring out how we're gonna draw all the measurements out and just get everything modeled. And communication. There was a lot of communicating on this project, and we learned that without proper communication, or I guess with proper communication, it just expedites the process because we can delegate certain processes to one another.
We also learned just some skills that came into being from the whole semester of learning. We learned and put into work our sketches, hand drawings of different models and stuff on paper, on the graph paper that you saw at the beginning of the slide. And we also learned and got better at our modeling on SolidWorks, just modeling the individual parts, and then when putting them all together, putting them into assemblies and how they work, and then putting them on drawing documents and making a clean, legible, easy to understand, and clear drawing. And then we also, at the end, we came up and got better and learned SolidWorks simulations and animations.